Okay, our next presentation is from AJ Brown, and he is a second-year PhD student in soil and crop sciences. And he knew he wanted to study soil and crop science when he saw the impacts that agricultural research and extension had on his own hometown of Rocky Ford, Colorado, which is where he grew up. His title today is Mitigating Adverse Effects of Soil Salinity on Global Crop Production, New Approaches to Irrigation and Water Table Management.
Agriculture's newest challenge is efficiency. We have to produce more food with less land, less water, and fewer chemicals in order to feed an estimated 9 billion mouths by the year 2050. Irrigated land produces 40% of the food that we eat, but unfortunately a large amount of it is significantly impacted by soil salt. Soil salt, you might ask, what does that have to do with agriculture? Well, salts affect plants in two main ways. The first way is that salt is actually toxic for plants, and so it can result in reduced yield directly. And the second way is that salts, when dissolved in water, make it so that the plants actually have to compete for water availability with the plant itself, also reducing yield. And so my research is focused on being able to find these results in these plants. And so all natural waters contain various amounts of salts, and that's a problem because that means that every land with evaporation exceeding the application of water will result in soil salt accumulation. And so my project is based off this principle. The Pakistan and US government asked us to locate and find salts and common agronomic issues and solutions between the Indus River Valley of Pakistan and the Arkansas River Valley of Colorado so that we can apply it to the world. And so my objectives as a PhD student are threefold. Number one, where are the salts located in the valley? Number two, how are they affecting the plant growth? And number three, how do we solve this issue? And so to find the salts, the first thing that we did was we used an electromagnetic device that told us where to sample for soil salts. And once those soil salts were analyzed, we were able to correlate the salt concentrations back to those electromagnetic fields. Basically, it means that we don't have to soil sample any longer, and we can non-invasively look at the salt concentrations within a field, such as that map right there. And eventually, we'd like to upscale this to a remote sensing satellite image where we could perhaps locate salts in an entire river basin using satellite imagery and small amounts of soil sampling. The second thing we looked at was how they affect the crops. And so to do that, we installed soil sensors that could observe water content and salt content throughout the growing season in the corn. And what it showed is that because rivers divert in order to transport water to the field, such as much of the world does, the water was actually seeping up from under the crop and into the root zone, bringing along salts with it. And this created the problem in up to a 50% reduction in corn yield for just simply diverting water. And so our proposed solutions to these and ways to mitigate this risk are, number one, to make sure that when you have a field, to make sure that the soil is properly drained. That is somewhere where the salts can go to after an irrigation. Number two, make sure that you have an area where the salts can go. And number three, make sure that you identify the kinds of salts because it will require different leaching. Salt can be managed. Thank you.